So number one is a review. We are going to factor by grouping here. So I'm going to underline the first two terms. And ask yourself, what can you factor out of these two terms? I can take out a maximum of 2x's, so x squared. And now I need to determine what goes inside parentheses. So 1 times what value equals 2? 2. You need a total of 3 x's, and you only have 2, so attach one more. 1 times 3 is 3. You need 2 x's. You already have the 2 x's. Take what's in parentheses, write it behind. I'm going to put a really light question mark in front that I'm going to be able to erase or write over the top of later. Find what number can you take times 2x and end up with negative 8x. The answer is negative 4, but it has to work for the second numerical value as well. So negative 4 times 3 is negative 12. I'm good to go. I write down what the front and the back have in common, what's in front of the first group, and what's in front of the second group. If you stopped here, you would not be correct because you can continue to factor. X squared minus 4 actually factors into x plus 2 and x minus 2. This is the fully factored form of this expression. Moving on to problem number 2. Number 2 is a problem where you're going to be factoring the difference of cubes. So I'm going to go through this because it's been a while as if you've forgotten. So it's called the cube root of 8, and that means what number times itself 3 times equals 8? The answer is 2. Cube root of x cubed is x. Cube root of 125, again, that means what times itself 3 times gives you 125, and it is 5. So with all cube root, whether you're finding the sum or the difference of cubes, you have 2 positions in the first and 3 in the second. And in this position, it will always, always, always be a plus sign. In the first position, it will be the sign of the problem. And whatever sign you use here, in the middle, you'll use the opposite sign. Okay, I'm going to use one of the 2's and one of the x's, then I'm going to cross them out, and one of the 5's. In the next position, I'm going to use the remaining 2's and the remaining x's. So that gives you 4x squared. In the very, very back, I'm going to use the 2 5's. 5 times 5 is 25. Now, how do you get the second parenthesis in the middle? You take the first 2 terms and you multiply them. Forget about the sign. 2x times 5 is 10x. This is the factored form of the expression above. So those are a review of what we did in Unit 2, and right now this is the beginning of Unit 5. We're going to go on to number 7. Please make sure you're quiet so everybody can hear. Please make sure you're quiet so everybody can hear. Okay, we're going to simplify, and then this is new for a lot of us. We're going to state the excluded values. And underneath that, please write what value makes the denominator equal to 0. Okay, so this is factoring in trinomial like you learned freshman year, and we reviewed again using the bottoms-up method. So what we're going to do together, and I'm going to come off to the side. My final answer will be down below. Okay, so this multiplies to give you a positive 60 and combines to give you a negative 17. And I made an initial mistake with this. So 1 and 60 no, 2 and 30 no, and initially I said 3 and 20 yes. And don't write this down. But I said, okay, that'd be a negative 20 and a positive 3. And that is true to combine to give you negative 17. But does negative 20 and positive 3 multiply to give you a positive 60? Nope. So we're going to keep going. 4 and 15, no. What about 5 and 12? 5 and 12 work, but they both have to be negative. And by both being negative, they combine to equal negative 17 and multiply to give you positive 60. Okay, once you've selected the two values, we're going to take the leading coefficient and write it underneath both. And then we're going to go ahead, and if it's possible, we're going to reduce the fraction. If the fraction can't be reduced, we are going to do bottoms up because we're not solving right now. We are factoring. 12 divided by 6 is 2. This is the numerator in factored form. The denominator of the first fraction is x plus 4. Now I'm going to come to the second fraction and I'm going to factor the numerator. So multiplies to give you -8, combines to give you +7. Okay, that's going to be x plus 8 and x minus 1. Don't forget to do bottoms up again, so put a 2 underneath both. If it can reduce, reduce it. If it's in a fraction after it's been reduced, then we're going to push up the bottom number. Okay, I'm going to do the bottom one. What multiplies to give you 4 and combines to give you -5. +4 multiplies, combines to give you -5. X minus 4 and x minus 1. They multiply to give you +4, combine to give you -5. Take the leading coefficient, put it underneath both. If it is possible to reduce, then do so. If it's still in a fraction form after it's been reduced, push up the bottom number. Okay, our next thing is we are going to cancel. You can cancel anything on bottom with anything on top, but they have to be identical. So anything on the bottom can be canceled with anything on top. A common misconception is students think, well, can I cancel an x plus 4 with something that's kitty corner to it? Yes, you can do it with something that's kitty corner to it. Anything on the bottom with anything on top, but you can't do top with top or cancel bottom with bottom. So I'm going to put a line over x plus 4 and a line over x plus 4. They're being canceled. I'm checking, is there any x minus 2's? There is. So x minus 2 and x minus 2. And there's also an x minus 1 and an x minus 1. Remember, when you cancel something, actually, those two things turn into 1's. So this turns into a 1 and 1, a 1 and 1, and a 1 and 1. So really, on top, I have a 6x minus 5, and on the bottom, I have a 1. But dividing by 1, does that do anything for us? Does it change any value when you divide by 1? So this simplifies into 6x minus 1. That is the simplified form of this expression. Since there's no variables in the bottom, you don't have to worry about is there a number that's excluded. So there's no variable down here in the denominator right now after it's reduced to cause the denominator to equal 0. So we're going to put an example of the empty set. Please make these squiggly parentheses and put nothing inside. It is the empty set. We have completed this first problem, and now we're going to go on to number 8. Okay, problem number 8. The top appears to be factoring by grouping. So I'm just going to put a line here. I can see that I can take 2 x's out of both, but there's also a numerical value. What is the largest numerical value I can divide by both? A 4. So 4 times 2 is 8x squared. I need 3 x's. And 4 times 3 is 12. I need 2 x's. I already have that. Leave a space, 2x plus 3. Put a light question mark in front. What value times 2x equals negative 18x? That'd be a negative 9. And let's check, is negative 9 times 3 negative 27? It is, so I can proceed. Both the first group and the second group have a 2x plus 3. Then what's in front of the first and what's in front of the second? If you stopped at this point, you would be wrong. You're not done. 4x squared minus 9 factors into 2x plus 3 and 2x minus 3. This is the numerator factored, okay? Then I'm going to put a division line down, and now I'm going to go ahead and I'm going to factor the bottom, the trinomial at the bottom. So 10 times negative 3 is negative 30. What multiplies to equal negative 30 and combines to give you 13? X plus 15 and x minus 2. Take the leading coefficient, place it underneath both numerical values, and now reduce the fractions. So 15 over 10, when I divide both by 5, it equals 3/2. And 2 over 10, when you divide both by 2, it equals 1 over 5. When I rewrite it down below into this position in the denominator, I've already reduced the fraction, so I'm going to push up the denominator. So it equals 2x plus 3 and 5x minus 1. Okay, let's cancel. Here's 1, 2x plus 3. I can only cancel 1, 2x plus 3 on top. I can't cancel them both. Only cancel 1 for 1. Remember, when you cancel, it really turns into a 1 then. And there's no 5x minus 1. So really, this is my answer right here. 2x plus 3 times 2x minus 3 over 5x minus 1. Don't take time to foil the top. Just leave it in this form, factored form. This is your answer. And the last step is to determine the excluded values. So remember, we don't want the bottom to equal 0. And this is different than the previous problem that had no variable in the bottom. So there is a number I can plug in here, and this equals 0. And here's how you determine it. Take that expression, 5x minus 1, and set it equal to 0. We're going to solve for x. So first I add 1 to the opposite side. You should be writing this all down on your paper. And then you divide by 5. So x equals negative 1/5. The excluded value is negative 1/5. Because first, I'm sorry here. I couldn't see my writing. That's a positive. Thank you, Chris. Add 1 and then divide by 5. I misread the equal sign for a negative. What does this mean? It means if you substitute 1/5 in for x and you evaluated this expression, you'd end up with a 0 on the bottom, and that's a rule you can't break. You can't have a fraction and a 0 on the bottom. So you can plug in any number you want, but it cannot be a positive 1/5. This means there's no restrictions what values you plug in for x and evaluate. Please go on to number 9. Now, what's different about number 9? If you remember back to 4th and 5th grade, when you start working with fractions and you start dividing fractions, division turns into multiplications and you always flip the second fraction. Brian, see you later. I don't have time for sleeping class. See you later. Don't put your head down. See you later. You sneezed?
Yeah.
And you put your head down?
I sneezed until my eyes.
Okay. Don't do it again. So if you sneeze, just let it fly. Okay? If it hits Ann on the back of the head, that's okay. But I don't want to think you're sleeping. All right. Here we go. Look at the numerator. What can you pull out of both of these? A 6. What else can you pull out? An x squared. So everybody write a 6x squared. 6 times 1 is 6. You need 3 x's and you only have 2. Attach 1 more. 6 times negative 2 is negative 12. You need 2 x's. You already have them. So the numerator is done. I'm going to go off to the side and I'm going to factor this trinomial. So I'm looking for two numbers that multiply to give you negative 4 and combine to give you negative 3. So negative 4 and negative 3. So combined to give you negative 4 would be x minus 4 and x plus 1. They multiply to give you negative 4, combined to give you negative 3. Remember, in the rush of things, often students forget to do bottoms up. So I take the leading coefficient and I put it underneath each numerical value. 4 divided by 2 reduces to negative 2. 1/2 cannot reduce any further, so we push up the 2. 2x plus 1. Turn division now into multiplication. And we can see that this was the denominator. There's nothing you can do to factor out an x or any value greater than 1. So I'm going to just write 2x plus 1 on top. On the bottom, this was the numerator, but it will now go into the denominator position. I can factor a 12 out of both terms and an x cubed. Twelve times 1 is 12. You need 4 x's and you have 3. Attach one more. 12 times 2 is 24. You need 3 x's and you already have them. Okay, here is an x minus 2. Here is an x minus 2. Canceling them out. Here's a 2x plus 1 and a 2x plus 1. Canceling them out. Really remember, when you cancel them out, they really both turn into 1s. Here's an x plus 2. There's nothing on top. That's an x plus 2. But 6 by itself and 12 by itself do reduce. 6 goes into itself 1 time, and 6 divides into 12 2 times. The last thing I'm going to take care of is the x squared on top and the x to the third on the bottom. So I'd like you to think of it like this. You have 2 x's on top, if I expand it, and 3 x's on the bottom. 2 x's on top and 3 on the bottom. And if you cancel 1 x on top with 1 on the bottom. So there's canceled, but you have 1 remaining and it's on the bottom. So these got canceled and you have 1 remaining on the bottom. Okay, so when I write my final answer, I have 1, really these cancel, so 1 times 1, that cancels, and that cancels. Remember, when it cancels, it turns into a 1. So 1 times 1 times 1 times 1 is 1. On the bottom, there's a 2, there's an x to the first, and there's an x plus 2. Now you don't have to write x to the first. It's assumed that if you just see an x, it's x to the first. And if you want to put a 1 in front of the x, you can do that as well. It's not really required. So here is your simplified form of the expression above. Now, both this factor and this factor, both this factor and this factor can give you an answer of 0. So let's start with this one. What number could you substitute in for x and this portion would now equal 0? So what plus 2 equals 0? Negative 2. Put a comma. And what number can you plug in here? And 2 times that number equals 0. So 2 times what value equals 0? 0. Sometimes students will say negative 2. No, 2 times negative 2 is not 0. 2 plus negative 2 is 0, okay? We're multiplying. 2 times 0 is 0. The order you write these in does not matter, okay? So what does this mean? It means if you go up to the original problem or the simplified problem, if you ever substitute in a 0 for all the x's or a negative 2 for all the x's, you'll end up with an answer that has some value over 0, and you can never have 0 on the bottom. It's breaking a math rule. Going on to number 10. X squared minus 9 reduces to x plus 3 and x minus 3. All right, so whenever you add or subtract fractions, you must have a common denominator. So I can see on the left I have an x plus 3 and an x minus 3, and on the right I have a 9. So if I think of a good common denominator, it would be 9 times x plus 3 times x minus 3. Some students say, well, why did you put the 9 in front when it was over here? We generally take any coefficient that's just a numerical value and we place it in front. Now make a long division sign across the top. The left-hand fraction, it has an x plus 3, it has an x minus 3, but it's missing a 9. So I'm going to take a 9 and I'm going to attach it with the 3. Bring down the subtraction sign. Now the right-hand side is a 2. But this side has a 9, but it's missing an x plus 3 and an x minus 3. So yes, I could write, don't put this down please, but I could write x plus 3 and x minus 3 because that's what it's missing. But a shortcut, what else equals x plus 3 times x minus 3? Look over here. What is equivalent to x plus 3 times x minus 3? X squared minus 9. That's what we factored to. Those are equivalent expressions. My next step is I'm going to take this and I'm going to multiply, do order of operation here. So I have 27. Now I'm going to distribute minus negative 2x squared plus 18. Okay, writing this in standard form and combining like terms. Negative 2x squared plus 45 when I combine like terms. And then the last thing you want to ask yourself is, in the numerator, can I take an x out of both terms on top? Can't do that. Can I divide both terms by negative 2? Nope, can't factor anything out. That means this problem is factored. This problem is simplified. So this is equivalent to this original problem. What problems or numbers must be excluded? Well, only these two parts can make the denominator equal to 0. So if you plugged in a 3, 3 minus 3 would equal 0. So can't have a 3. And if you plugged in a negative 3 plus 3 is 0. Can't have a negative 3. Those are the two excluded values. That means whether it's the original problem or the simplified problem, if you substituted a 3 where you see an x or a negative 3, you'd end up with a 0 in the denominator. It's breaking a math rule. Can't do that. Flip and find number 11. Okay, so we're going to start with the numerator. What multiplies to equal negative? What multiplies to equal negative 28 combines to equal negative 12. 1 and 28, no. 2 and 14, I think 2 and 14 will work. So it's going to be x minus 14 and x plus 2. Don't forget to divide both numerical values by 7. Okay, I'm going to reduce x minus 2. And since this fraction 2 over 7 cannot be reduced, we push it up, the bottom value in front of the x. This is the factored form of the numerator. Okay, now I'm going to factor the denominator. 14 times 2 is 28. What multiplies to give you 28, once again, this time it's positive, and combines to give you 11. That'd be x plus 7 and x plus 4. Take the leading coefficient of 14 and write it underneath both numerical values. 7 over 14 reduces to 1/2. 4 over 14 reduces to 2/7. Okay, since both fractions are already reduced, we're going to push up the bottom number. 2x plus 1 and 7x plus 2. I'm going to reduce by canceling out the 7x plus 2. And what I have remaining is the final answer for the simplified form. Now, how do you determine what the excluded value should be? Again, you take the denominator, and when it has a number in front other than 1, sometimes it's easier for you just to set it equal to 0 and solve. So what makes the denominator equal to 0? I subtract 1, divide by 2, and the excluded value should be negative 1/2. If we plug negative 1/2 in for x in the reduced, the simplified form, or the original problem, we'd end up with a 0 in the denominator. on right now to number 12. Okay, so I can see this is going to be a difference of cubes. So I'm going to write down 2 positions and 3 positions. In the very back, the operation will always be addition. Because subtraction is right here, I'll have subtraction in the first operation position. And if this is subtraction, this will be the opposite, which is addition. So really, this is 1, 1, 1, x, 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 and 5, 5, 5. So I'm going to bring down a 1 in the x. You don't have to have a 1 there if you don't want. And a 5, and then I'm going to cross them out. In the next position, 1 times 1 is 1, x times x is x squared. So I'm going to write a 1x squared, but again, you don't really have to have a 1 there. It doesn't change the value. Please make sure you're writing all of this down. Then in the very back, 5 times 5 is 25. Ruben, do you have it all done? How do you get this value? You multiply these two, forgetting about the sign. 1x times 5 is 5x. There's the numerator of the first fraction. Below it, I'm going to write x plus 3 because there's nothing I can do with that denominator. I can't factor out any value. Okay, in the numerator of the second fraction, 2x plus 6, although I can't take an x out of both, I can divide a numerical value other than 1. I can divide by 2. 2 times x is 2x. 2 times positive 3 is positive 6. On the bottom, x squared minus 25 reduces to x plus 5 and x minus 5. So x plus 3 and x plus 3 cancel. There's no x plus 5 by itself on top, but there is an x minus 5. So on top, I'm going to put 2 in front, followed by 1x squared plus 5x plus 25. On the bottom is going to be x plus 5. What is excluded? Francisco, what is the only value that if you plug it in for x, you're going to get a 0 on the bottom? Negative 5. And if you're confused, again, you can always take that expression, set it equal to 0, and solve, and you'll get the same answer of negative 5. Please go on to number 13 next. Number 13. Okay, for number 13. In the numerator, 10x squared plus 50x. I can divide both terms by 10, and I can also take a maximum of 1x out. 10x times x is 10x squared. 10x times 5 is 50x. In the denominator of the first fraction, what two numbers multiply to equal negative 24 and combine to equal 5? X plus 8 and x minus 3. Remember, division turns into multiplication. You take the second fraction and you're going to take the reciprocal of it. It means you flip it. So the 30x will go on the bottom. And since I can't factor anything out of 30x, I'm just going to write 30x on the bottom. Then I'm going to take this trinomial that originally was in the denominator of the second fraction. I'm going to come off to the side and I'm going to factor it. So what multiplies to equal 16 and combines to equal positive 17? X plus 16 and x plus 1. Divide both numerical values by 2. And then reduce the fractions. If the fractions can't be reduced, push up the bottom number of the fraction. Okay, so x plus 8 and x plus 8 cancel. There's no group of x minus 3 on top. There is a single x on the bottom by itself and a single x on top by itself. 10 divides into itself one time. 10 divides into 33 times. So on top, I have 1 times 1 times 1, and then I have these two groups of x plus 5 and 2x plus 1. If you want to write a, bless you, if you want to write a 1 in front, you can do that. On the bottom, we have a 3 and an x minus 3. Okay, so when I look at the denominator, nothing I can do with the 3 would somehow cause the denominator to equal 0. But for this group, what could you plug in for x and this portion would equal 0? Anyone? 3. So the excluded value is 3.